Hello everyone, let's take a look at our next problem. If x and n are integers, then 1 minus x to the n times 2 minus x to the 2n, and so on, up to 5 minus x to the 5n, is, okay, we have a bunch of options. Negative when n is greater than 5 and x is less than 5. Negative when n is odd and x is greater than 5. Negative when n is a multiple of 3 and x is greater than 5, or negative when n is even and x is less than 5. Right. So, I guess we're just looking at the parity of things, right? And we're keeping in mind that an even number raised to an integer exponent is always even, a positive integer exponent. An odd number raised to a positive integer exponent is odd. And then just going from there. Oh, sorry, we're not, what am I talking about? We're not worried about evens and odds. We're worried about positivity, okay? So we have to worry about whether the exponents are even or odd, and whether the bases are positive or negative. And I think it might be worth it to just work this out by the process of elimination. What I'll do is I'm going to write this big expression out and then just go through the four options, A, B, C, and D, and kind of argue whether, you know, if I'm doing option A, if I assume n is greater than 5 and x is less than 5, can I conclude that this thing is negative? In fact, now that I'm looking at this, so this, n is an integer. So that will always be positive, and that will always be positive, because the if n is an integer, then these exponents will be even. 2n and 4n are even. Do I have to worry about negative exponents? Not really, right? A negative exponent will just give us a reciprocal, and then we're back to worrying about positivity and negativity. So because we're looking for when this whole thing is negative, these two numbers are always positive. I can ignore them. So I'm actually just going to delete them here. Okay, so now the sign of each of these things, if n is even, this is positive, the whole thing. So in fact, I can eliminate option D right away. Option D says that this is negative when n is even and x is less than 5. So this, if n is even, this is never negative. So I can assume that n is odd. And then we just need to worry about the sign of these three things. The sign of this number is just going to be the sign of the products of these three numbers, okay? So I need n to be odd. So in fact, the only one that satisfies that is option B. Which is when n is odd and x is greater than 5, right? If n were even, this could not be negative. So what we need is n to be odd, and we also need all three of the, well, we need either one or all three of these numbers to be negative. And if x is greater than 5, that'll be negative, that'll be negative, that'll be negative. So there we go. The original expression is negative under option B when n is odd and x is greater than 5. Yeah, that was a nice little sort of deductive problem. it helped to, when you're talking about positivity, negativity, or also parity, like whether a number is even or odd, just understanding how positivity and negativity interact with even and odd exponents, recognizing immediately that the second and fourth term are always going to be positive. It didn't really matter too much in the end, but I suppose it was convenient to eliminate those, and then the remaining exponents were either all even if n were even, or all odd if n were odd. And then it was just kind of going through the four options and eliminating them, or seeing that in fact option B is the only one that specified that n is odd. That was a nice problem. If I have any more thoughts, or if I find an error of some kind, I'll put it in the description below. Otherwise, thanks for watching.